So in this video, I'm going to be demonstrating the inclined plane and friction lab for Physics 185 at the University of Rhode Island. So what this lab aims to do is to explore different types of friction that you can see in nature. So I'm going to start by explaining what friction is. So friction is the force that arises between two objects that are in direct contact with each other. So there are two different types of friction that we're going to try to explore throughout this lab. The first of which is kinetic friction. So kinetic friction is the type of friction that applies when the two objects that are in contact with each other are moving. So to explore that, we're going to have this setup here, which we have a wooden block resting on a metal track. We have a pulley system with a hanging mass, which connects to the block by some rope. So the point of this first step is we're going to try to see if we can accurately ascertain the coefficient of kinetic friction. So we want to do that by seeing if we can exactly match the force of kinetic friction when this block starts to move along the metal track. We're going to do that by trying to induce a constant velocity in this block via the hanging mass. So we want a constant velocity because if it's constant, that means there's no acceleration, which would imply that the net force on the block is balanced. So that would further imply that the hanging mass, so the weight, the gravitational force on that, which directly translates into the tension in the wire, is equally opposing the kinetic friction that is trying to stop the block from moving in the first place. And that highlights an important aspect of friction in itself, is that friction always applies opposite to the direction you are trying to move. So if we have those two forces perfectly balanced, with a slight push, you will see the block start to move at a constant velocity until we run out of rope and it's eventually forced to stop. So in the experiment, you would mess around with different masses on the hanging weight and on the block until you can get it to move with a slight push at a constant velocity. You would pretty much be easily be able to see if it was accelerating or not. You would see it moving faster and faster each second. So when you do that, you would want to wait until that constant velocity and then try it for a couple different masses on the wooden block, and then average out your results and try to calculate the coefficient of kinetic friction. So for part 2 of this lab, we're going to investigate static friction, which is the force of friction that applies when your object is not yet moving. And it actually supersedes kinetic because in order to get an object moving in the first place, you need to apply enough force to make sure that you break the static friction. So if you apply just enough force so that it's equal to the amount of static friction, your object will slide at a constant velocity like we saw in part 1. So that's what we're going to try to do here. But instead of using the pulleys and weights again, we're instead going to just increase the level of this track. We're going to increase the angle until we can see this block start to slide by itself. Now what that would imply in this case is instead of the weights and the tension equaling our kinetic friction, if we increase the angle of the plane and the block starts moving, that means whatever portion of gravity is parallel to the plane is equaling our static frictional force. So again, we want to only raise it in small increments until we can just barely start to see it moving at a constant velocity. So that's what we're going to do now. We're just going to slowly raise this until we can see it moving. Alright, so right about there. So as you can see, at a certain point, the block started moving on its own. So that would imply we finally added enough force to break the static force, the static friction force. So we've applied enough so that we've matched the static force, and now it's moving on its own. So we've perfectly balanced out all the forces in this system. So then what we do from here is take note of the angle of incline that we had to set this plane to, use that to find the portion of gravity that's parallel to the plane, and compare that to the static frictional force to try to find the coefficient of static friction. So once you've done that, you've pretty much completed the experiments, and we've seen the differences between static friction, which applies when we're not moving at all, and kinetic friction, which starts to work as soon as we actually break the static friction and begin moving.